Okay, part 2, question number 1. And ask you to write linear model based on the data shown up here. So in order to get a linear model, first you got to design your variable clearly. So suppose big G is the number of teenagers underwent gastric bypass surgery. I use G because it is the initial for gastric surgery. And also T is years since 2000. And you want to build a linear model based on the variable you design. So basically, G will equal to A times T plus B, where A and B are unknown numbers. So you need to calculate them based on the data you have. First, let's calculate the slope A. In order to get that, you need 2 points. So here we have 2 points. The first one in the year 2001, 408 teenagers underwent the surgery. So T equal to 1, G equal to 408. Second point is from this sentence here. In the year 2003, 771 teenagers underwent the surgery. So that means T equal to 3, G will equal to 771. And from that, you want to calculate A. You know that A, the slope, will be the change in Y over the change in X. In this case, we do not use X and Y, we use G and T. So G2 minus G1 over T2 minus T1. Suppose this first point is the point 1, so it has the format of T1, G1. And for the second one, this point will have the format of T2, G2. So you are ready to plug in everything. So your A will become 771 minus 408 over 3 minus 1. And if you put that into your calculator, they will tell you it will be 181.5. So that's your A, the slope. Then next, you want to calculate B. How to get that? Now you have A, and you can plug in the equation with one of those points. I choose the point 1 because it looks easier. So T equal to 1, G equal to 408. And you want to solve for B. You want to plug in this one in this equation to solve for B. So 408 will become 181.5 times 1 plus B, minus 181.5 on both sides. Then B will become this 408 minus 181.5. If you put in the calculator, they will tell you the number for B immediately. So that's 226.5. So now you have your A, you have your B, you are ready to write your model. So for the linear model, G of T, we use this format, the function notation, to indicate G is a function of T. So G of T is A, which is 181.5 times T, plus your B, that's 226.5. So that's for part A. So for part B, they want you to use your model to do some calculation. So for the year 2006, what's the number of teenagers having the surgery? So we have this model here. I copied here from the previous page. And now we know that in the year 2006, since T is the years since 2000, so that means T is equal to 6 for the year 2006. So you can plug in T equal to 6 into your model. So G of 6 will become 181.5 times 6 plus 226.5. So if you use your calculator, that will become 1315.5. So that should be the number of teenagers having gastric bypass surgery. But wait, the number of people should be integer. But now, this one is not. Then how do we deal with that? we need to round it to the nearest integer. So what we do is look at the next digit to the right. If it's 5 to 9, we round up. So in this one, it's 5. So we know that we will add 1 to our number. So we know that the number should be 1316 for the number of teenagers having the surgery. So that's for part B. Number 2, woman's optimal weight is 100 pounds at 5 feet and 130 pounds at 5 feet 6 inches. They want you to write a linear model for the woman's optimal weight based on the number of inches above 5 feet. So first, let's define a variable. So suppose big W is a woman's optimal weight in pounds, and H is the number of inches her height is above 5 feet. So we want to know, we want to build a linear model based on that. So W is equal to A times H plus B. Again, we need to calculate A and B. So A is the slope. Let's calculate that first. So first we need 2 points. So for the first point, so is the optimal weight is 100 at 5 feet. So that will become 0 inch above 5 feet, so 0, comma 100. The second one is based on the data that 100 pounds at 5 feet 6 inches. So 6 inch above 5 feet. So your first variable equal to 6. Second one is 130. So based on that, we want to calculate your A slope. In this case, it's W2 minus W1 over H2 minus H1. So that's the first point, and this is the second point. Then we will plug in W2, W1, and H2 and H1. So it's 130 minus 100 over 6 minus 0. The calculator will tell you that equals to 5. So that's for A. Then next, we want to calculate B. So we have A equal to 5, and we will use one of the points. H equal to 0, W equal to 100, and plug into your equation to solve for B. So 100 will become 5 times 0 plus B. B will become 100. Now we are ready to write our model. W of H equals to 5H plus 100. So that's your model. Then part B, according to the model, what is optimal weight of your math instructor if she is 5 feet 8 inches tall? So according to the variable we define, we know that here H will become 8. So we'll plug in H equal to 8 into our model. So W of 8 will become 5 times 8 plus 100, which is 140. So that means the optimal weight is 140 pounds. That's part B. Question number 3. Find the inverse function of the model. So first, you want to write your model, but not using the function notation. So it's easier for the calculation. So D equal to 650 times T plus 8400. Then you want to solve for T. So you minus 8400 on both sides, then divide by 650. So now T is a function of D. That's your inverse function. So T of D, that indicates T is a function of D. Equals to, you copy this thing here, D minus 8400 over 650. So that's for the inverse function calculation. For the second part, when the tuition was $7,700 9,700. What is the year? So that means when D equal to 9700, what is your T? You can put that into your inverse function. So T of 9700, you just plug in D equal to 9700 into your function. So that's 9700 minus 8400 over 650. So the calculator will tell you that equals to 2. So that means 2 years since 2000. Basically, that's the year 2002. So that's when the tuition was 9,700. That's part B. Question number 4. Find the inverse function for the model, very similar to the previous one. First, we will just use one letter to represent each variable. So we'll use P instead of P of D. So P equals 4.5 times D minus 300. We will solve for D. We add 300 on both sides, then divide by 4.5. So your D will become P plus 300 over 4.5. Then you want to use a function notation for the inverse function. So D of P will become this fraction here, which is exactly the same as that one. That's part A. For part B, you want to find the number of dolls needed to produce a profit of 20,000. So you know that big P is 20,000. You want to know what is D. You can go to your inverse function. So D of 20,000 will become 20,000 plus 300 over 4.5. And if you want put it in your calculator, that will become 4511.1111 and so on. But the number of dolls should be an integer. So we should really round it as an integer. So someone might say, okay, it's 1 here. So maybe we should just get rid of those numbers. So the number of dolls should be just a 4511. But is that right? Suppose we only have 4511 dolls. That means our profit will be slightly smaller than this 20,000. It will not actually reach that number. So in order to actually reach the profit of 20,000, we had to add one more doll. No matter what the digit to the right of this integer part. So we need 4512 dolls in order to reach a profit of 20,000. That's part B.